Hello everyone, this is section 2.1, inductive reasoning. So let's see what inductive reasoning is. They define it here. It says inductive reasoning is a process of observing data, recognizing patterns, and making generalizations based on those patterns. So you're just looking at something and you're looking at patterns, and then you're going to make predictions based on those patterns. So for example, if the sun rises every morning, you can pretty much predict that the sun's going to rise again tomorrow morning, and that's basically inductive reasoning because you're making that conclusion based on your observations. All right, here's an example. They say in physics, Dante's group dropped a ball from different heights, measured the height of the first bounce, and they recorded the results. So they dropped it from 120 centimeters. The result was 90. That's how high the ball bounced. They dropped it from 100, it bounced up to 74, so on and so on. So it looks like this is about, let's see, what is 90 of what's 90 over 120? So what we're looking for is, we're looking at what percent the ball bounces back. So 90 divided by 120 is 0.75. So 75%. It bounced back 75% of the original height. The next one, that one's pretty straightforward. It's 74 out of 100, which is 0.74. So all these are close to the same percent, 75%, 74%. The next one is 122 out of 160. That's about 122 out of 160 is approximately 0.7625. The next one, that one's 30 out of 40. That's 75%. And then the next two are going to be similar, and you can see the decimals here. And so our conjecture would be that the ball's going to bounce about 75% of the original height. And so that's our conjecture. All right, let's look at another example. They ask us to consider this sequence. They want us to make a conjecture about the rule for generating the sequence. So let's see if we can come up with the conjecture. Well, first they subtract 3 here, minus 3, and that's how you get 7. And then they add 2 to get 9. Subtract 3 to get 6. Add 2 to get 8. Subtract 3 to get 5. Add 2 to get 7. Subtract 3 to get 4. Add 2 to get 6. Subtract 3 to get 3. Add 2 to get 5. And so those are the next 4 numbers. All right, so that was a conjecture. And that was all based on inductive reasoning because we're looking at the patterns and determining what the next terms are based on the previous observations. All right, let's move on to the homework. So here's some sequences. Same thing, we need to find the next 2 terms. So let's start off with this one here, number 2. Looks like they're dividing by 2 to get 200. Then they're dividing by 2 to get 100. Then you divide by 2, you get 50. Divide by 2, you get 25. So that pattern continues. If you divide by 2, you're going to get 12.5. And if you divide by 2 again, you're going to get 6.25, so on and so on. This one's a little challenging. I looked at it and I finally got the next 2 terms. And the way we get that is, notice that it goes 8, 7. You would have thought it would have been 6, but hey, it can be 6. And look at the numerators, 1, 2, 3, 4. If this was a 3 and this was a 6, it would have been perfect. And sure enough, 3 6 is 1/2. So there is our pattern. Looks like the numerators are increasing by 1 and the denominators are decreasing by 1. So if we continue the pattern, the next numerator will be 5. The next denominator will be 4. Continue again, 6, 3. So once again, that's 1, 2, 3, 4, 5, 6, 8, 7, 6, 5, 4, 3. All right, number 4 is also kind of challenging, so I wanted to help you out with that one. So this one, we're going from -5 to 3, so it looks like we're adding 8 there to get 3. All right, and then to get from positive 3 to -2, it looks like we are subtracting 5. All right, So then I noticed that if you add those two numbers together, 8 minus 5, that's positive 3. So if you add 3, you're going to get 1. Negative 2 plus 3 is 1. And so then I just looked at these two numbers. If you add those two numbers together, you get negative 2. 1 and negative 2 make negative 1. And then if you look at the next two numbers, that's positive 1. Then negative 1 and positive 1 is 0. All right, and so that looks to be like the pattern. So then let's continue this pattern. All right, so we get 0. So wait, how are we going to do this next one? So these two make plus 3. These two make negative 2. These two make positive 1. These two make negative 1. And so now you have 0 minus 1 is minus 1. And then you go these two, which is 0. Negative 1 plus 0 is negative 1. That one was a challenging one. All right, let's look at the next type of problems. It says use inductive reasoning to draw the next two shapes in each pattern. So I'll let you do this one. Let's try this one together. It looks like you're starting off with the one figure. Now you break it up into two figures or pieces. Now you're breaking it up into 4 pieces. This one's going to have 8 pieces. So it looks like it's being multiplied by 2 each time. Times 2, times 2, times 2. So the next one should be 16. And the next one should be 32. So to draw the next box, you would draw the same picture. Well, that's not the same. Approximately like that, maybe. You would cut that. Well, I'm just going to redraw the 8 one. Whoops. I already messed up. Well, basically what you want to do is just cut this in half. You cut that in half and this in half. And now you have 16 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this picture would go there. All right. And then if you do that again, you're going to double it again by drawing there. Whoops. Yeah, it's not going to show up for some reason. There we go. All right, let's see if that is 32 squares. So we got 1, 2, 3, 4. And you got 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8. So 8 by 4 is 32. So that was the next one. So it's a little bit hard to draw, but that's how you would draw it. All right, let's move on to the next section, which would be 2.4. We skipped 2.2 and 2.3. So here's 2.4, which is deductive reasoning. This is a different type of reasoning. So this type of reasoning is a process of showing that certain statements follow logically from accepted facts. So this is different from inductive. Inductive is you're looking at patterns and drawing conclusions from the patterns or predictions, and this one is you're reaching conclusions based on logic and accepted facts. You can read more about it on page 114 in the textbook, which I've published. So here's an example. Say you're given an algebraic equation, and they want us to solve the equation, and then they want you to justify each step using deductive reasoning, accepted facts. So the first step here is, this is the original equation, nothing going on there. Next step, they distribute. So therefore, that's the logic. That's the accepted fact. In math, we're allowed to distribute. So that's that. And then looks like they subtracted 5x squared to both sides. And so that's subtract 5x squared from both sides. That's an accepted fact in math. You're allowed to do that. To keep the equation balanced, you do the same thing to both sides of the equation. And now it looks like what is next. All right, so that's that step. Now we're going to, it looks like they subtract 19x to both sides here. And that's exactly what happened. They subtract 19x to both sides, and you get negative 9x equals negative 45. And the final step is to divide both sides by negative 9. And that's what they say here, divide both sides by negative 9. And so that's an example of deductive reasoning. All right. Let's look at this conjecture. If an obtuse angle is bisected, then the two newly formed congruent angles have a measure that's greater than 45. So let's see why that's true. So here's a deductive argument. Let A be the measure of an obtuse angle. We know by definition that an obtuse angle is greater than 90 degrees. So let's say we multiply both sides of the equation by a half, because we're bisecting it. When you bisect something, you cut it in half. So you multiply both sides of the equation by a half. So over here you got 1/2 A. Half of 90 is 45 degrees. So therefore, the newly formed congruent angles have a measure that's greater than 45 degrees. All right, let's take a look at the homework. Here we go. So see, for number 1, it says ABC is equilateral. Is the triangle ABD? So we know ABC is equilateral. That means that these sides are congruent. And also, these all have to be 60, 60, 60. That's what an equilateral triangle says. All right, what about ABD? ABD is the bigger triangle. Is that one equilateral? Let's find out. Well, this is 60. This has to be, this is a supplementary angle, a straight angle. So if that's 60, this has to be 120, because those two angles have to add up to 180. 120 plus 60 is 180. But we can't really say much about these two angles. Maybe this is, let's say, maybe this is 30. If that was 30, that's 150. This would have to be 30. But what if it's 29? This would have to be 31. So we have no idea what this angle is and what this angle is. We just know that these two angles have to add up to 60, because 60 plus 120 is 80. But we have no idea what they are. So in this case, we cannot say that ABD is equilateral. So not equilateral. What type of reasoning? We use deductive because we were using accepted facts. The fact that this is equilateral, therefore this is 60, therefore this is 120. And the fact that these add up to 180, that's an accepted fact in geometry. And we're not able to determine these two because all we know is that they have to add up to 60, but that's not enough information to conclude that. Actually, never mind. We can conclude by a fact for sure that it's not equilateral, because in order for this triangle to be equilateral, this would have to be 60 degrees, but it's not 60. It's 60 plus a little bit more. So there's no possible way that this could be 60, and then this can't even be 60, because if this is 60, this is 180, this would have to be 0 degrees, but clearly that's not 0. So there's no way that that this could be 60, 60, 60. So not equilateral. Deductive reasoning. All right, let's look at these what-nots. This is a little strange. Which figures in the last groups are what-nots? So which of these are what-nots? All right, so let's look at what what-nots look like. Well, they all seem to be quadrilaterals or squares. You can probably say squares because they look like squares. They have dots in the middle or on the inside, at least one dot. And they have little squigglies coming out of the corners. So I think those are the defining characteristics of a what-not. Square, at least one dot, and squigglies coming from the corners. It could have one or it can have many. So this one fails to be a what-not because it doesn't have at least one dot. This one's not a square. This one does not have the squiggly on the corner. This one's not a square. This one's not a square. So this one is a what-not, according to our definition, so I'm going to circle it. I'll circle the whatnots. This one would not be, it's not a square. This is not a square. This one appears to be a whatnot to me because it's a square and it's got at least one dot, and it's got a squiggly coming from the corner. Same. Oh, nope, that one does not have a squiggly in the corner. It's got a squiggly here, which disqualifies it from being a whatnot. And this one does appear because it's got the squigglies from the corners and the dots on the inside. All right, this one, you would pretty much do the same thing as in the example problem. So let's do this one together. So first thing I would do is multiply both sides of the equation by 5 times 5 times 5. And that would be multiply both sides by 5. You're allowed to do that. So that's my first step. All right, so now I have 19 minus 2, 3x minus 1 equals x plus 2 times 5. Now I'm going to distribute. So now I have 19 minus 6x plus 2 equals 5x plus 10. So I distributed. All right, the next step is going to be, let's combine these like terms. 19 plus 2 is 21. Combine like terms. I'm going to abbreviate that CLT. And now I'm going to, let's add 6x to both sides. And now we have subtract 10 to both sides. And lastly, you're going to have 11 equals 11x divided by 11. X equals 1. So we divided both sides by 11. All right, so that's pretty much it for that one. Let's jump to the next section, which is 2.5. So they're going to talk about linear pair conjecture. The linear pair conjecture says if two angles form a linear pair, then the measures add up to 180. So here's a linear pair. That's 30. Then this must be 150. And it's a linear pair because it's a pair of angles and they're in a linear, they form a line, which makes them linear. All right, vertical angles conjecture. If two angles are vertical angles, then they are congruent. So here's an example of two congruent angles, or two vertical angles, I should say. This one, let's say this is 45 degrees. Then this one has to be 45 as well because they're vertical angles. All right, and then this is a linear pair. These two have to add up to 180. So if that's 45, then this must be, what would that be, 125, I believe? Let's see. Or is it 135? Yeah, it should be 135. 135 plus 45 is 180. Yeah. Okay. Here's an example. Use inductive reasoning to complete the conjecture. If angle B is a supplement of an acute angle A and C is a complement of angle A, then B take away C must equal. Ooh, that's interesting. So let's see. B is a supplement of A. All right, so B. So we know that angle B plus angle A equals 180 by definition. This one has to be acute because they tell you that. And angle C is a complement of A. All right, so angle C plus angle A has to equal 90. That's the definition of complement. Okay, so we already know that angle A is acute. So what is B take away C? All right, that's interesting. So let's see. Well, what I'm going to do is I'm going to subtract these two. So if you do B take away C, and then you do A take away A, those cancel. And then you do 180 take away 90 is 90. So it's got to be 90 degrees. And sure enough, there it is. So I just wrote two equations. Angle B and angle A are supplementary. Angle C and angle A are complementary. And if you subtract these two equations, B take away C is B minus C. A take away A, cancel out. 180 take away 90 equals 90. All right, let's look at the homework. All right, find each lettered angle. All right, well, let's jump into this one. All right, well, these are vertical angles, so they're congruent. So this is 1, 2, because they're vertical angles, and vertical angles are congruent. These angles are congruent. You can tell by the marking. Therefore, this has to be 112. These two form a linear pair, so they have to add up to 180. So what's 180 take away 112? That's 68 degrees. And then this is vertical angles, so they're congruent. And these are vertical angles, which makes them congruent now. All right, let's look at this one. Okay, well, you have a 90-degree angle. So if that's 70, that has to be 20. All right, let's see what else we have. We have another 90-degree angle here. If that's 20, that has to be 70. All right, and then we have a linear angle or a straight angle. So this plus this plus this plus this has to add up to 180. So 70 plus 20 is 160. Therefore, this has to be 20 to make 180. So yeah, just add up these angles and you should get 180. Yeah. All right, now for the rest of these form a linear pair. Therefore, they're supplementary, which makes this 120. 120 plus 70 is 180. That's a straight angle right there. And finally, same thing. These two form a linear pair, which means they're supplementary. So 120 plus 60 is 180. All right, let's look at a couple of these down below. All right, so these are always, sometimes, never. Let's look at, number 12. If A is congruent to B and a supplement of B has a measure of 22, then angle A, all right, let's see. The supplement of B has a measure of 22, so that means that angle B has to equal to 180 minus 22 because they're supplementary. 22 is supplementary to angle B, so that's how you find angle B. So what's 180 take away 22? Angle B has to be 158. All right, and since B is congruent to A, that means A is also 158 degrees. All right, let's move on to the next section. We're just going to do 2.6, and that's our last section that we're covering. So here we're looking at the definition of a transversal. All right, so a line that intersects two or more coplanar lines is called a transversal. All right, so we're going to look at what happens when we have two parallel lines. And we have a transversal. So here's a transversal. A transversal cuts across two parallel lines. So we're going to look at the angles that are formed. There's going to be some terminology. So it turns out that angle 1 and angle 2 are called alternate interior. What else do we have? We have corresponding angles would be, for example, angle 3 and angle 4. No, I'm sorry, angle 3 is not the corresponding to angle 4. Angle 3 and angle 4. All right, those are called alternate exterior. All right, so let's go down here. Corresponding angles. If two parallel lines are cut by a transversal, the corresponding angles are congruent. All right, so let's take a look at some other definitions. Alternate interior angles. If two parallel lines are cut by a transversal, then alternate interior angles are congruent as well. Alternate exterior angles. All right, that's what we drew up here. So these are alternate interior. Those are congruent. Alternate exterior. Those are congruent. All right, and then corresponding angles would be 3 and 5. So this one corresponds to this one. Those would be corresponding angles. Those are also congruent. So we already know that alternate exterior angles are congruent as well. Parallel line conjecture. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Alternate interior angles are congruent. And alternate exterior angles are also congruent. All right, let's take a look at some examples here. All right, if two lines are cut by a transversal to form a pair of congruent corresponding angles, congruent alternate interior angles, or congruent alternate exterior angles, then the lines are parallel. So that's called the converse. So this time they're saying if those angles are congruent, then the lines must be parallel. This one was saying if the lines are parallel, then those angles are congruent. So I think it's going to be a lot easier just to look at an example. So here's an example. All right, so they say, suppose that you assume that the alternate interior angles conjecture is true. Write a deductive argument showing that the alternate exterior angle conjecture must be true. You may assume that the vertical angle conjecture is true. So right away we know that L is parallel to M. We can tell by these arrows that tells you that those two lines are parallel. So therefore we have angle 1 is congruent to angle 3, right? That's by vertical angles. Also, angle 2 is congruent to angle 4. All right, and now let's see, what else do we have? Suppose that you assume that alternate interior angles are conjecture is true. So we're allowed to assume that these are alternate interior, that those are true. So now we have angle 1 is congruent to angle 2. Well, since angle 1 is congruent to angle 3, and angle 1 is congruent to angle 2, that means angle 2 is congruent to angle 3. All right, so we've made a deductive argument based on vertical angles and alternate interior angles. Therefore, 3 and 2 must be equal as well. All right, write deductive argument showing that the alternate exterior angles. So we're trying to show that alternate exterior would be these two are also congruent. So we need to show that 3 is equal to 4. All right, well, we know that we did that angle 2 is congruent to angle 3. Well, and since angle 2 is congruent to angle 4, and angle 2 is congruent to angle 3, therefore angle 3 and angle 4 must be true. And that's what we're trying to show. We're trying to show that alternate exterior angles are congruent, and we've shown that. Okay, let's go ahead and look at the homework for this one. All right, so by vertical angles, this one has to be 54. Well, alternate interior angles are congruent, so A is congruent to B, so this also has to be 54. And then vertical angles are congruent, so this also has to be 54. All right, and that's all because of these two angles being parallel and this being a transversal. Let's look at this one. Once again, They don't tell us that they're parallel. It says, use your conjectures to determine whether these two lines are parallel and explain why. If not enough information is given, right cannot be determined. Well, if this is 95, then this has to be 180 minus 95. Because it's a linear pair, so that's 85. Alternate interior angles are not congruent. This is 25, this is 85. These are alternate interior angles, and since they're not congruent, these lines cannot be parallel. So not parallel. All right. Let's try this last one. All right, what do we know about alternate exterior angles? We know that those are congruent. We also know that vertical angles are congruent. So let's start off with the vertical angles because you have x and x. That's going to make it easier to solve instead of y and x. So let's set these two equations equal to each other first. That's by vertical angles being congruent. 4x, add 4x, you get 9x, subtract 2, get 180, divide by 9. X is going to be 20 degrees, or just 20. All right, well, once you have that, you can say corresponding angles are congruent. We know that, so set that equal to that, but plug in 20 in for x. So 4 times 20 is 80. 182, take away 80 is 102. Let me just confirm that. Yeah, that's going to be 102 right over here, because the way I did that is I plugged in 20x, and I got 4 times 20, which is 80. 182 take away 80 is 102. These are corresponding angles, which are congruent. Therefore, you can set that equal to 102. Subtract 2 to both sides. You get 4y equals 100. Divide by 4, y equals 25. All right, and that's pretty much it. We will do 3.3 next class.